My name is Michelangelo D'Agostino, and I lead the data science team at a Chicago-based company called ShopRunner. I'm excited to tell you a little bit more about what we do at ShopRunner throughout the course of this talk. But before I get into all that, I wanted to learn a little bit more about you all in the audience. Yes, the dreaded audience participation part of the talk. I was hoping we could do a really quick show of hands. So how many of you would I identify as data scientists who are managing other data scientists right now? Okay, so that's maybe like half or 3/4 of the audience. And how many of you are data scientists who aren't currently managing data scientists but are interested and want to go that direction in your career? Okay, a couple hands. And then how many of you would identify as like technology executives or leaders who manage data science functions underneath you? Okay, so that's another big chunk of folks. So hopefully there should be something, I think, for all these different groups throughout the course of my talk. If not, I've intentionally cut the talk decently short so that there should be plenty of time for questions and discussion afterwards. So if any of you didn't raise your hand yet, so I guess it's time to scramble for that yellow piece of paper to figure out if you're actually in the wrong room. So I should say right at the outset, this talk is kind of a departure from talks that I'm normally used to giving. I'm used to giving very technical, code-heavy type talks. But as I started thinking about topics for the Strata Business Summit, it has this tagline, the missing MBA for the data-driven business or something like that, and started thinking about some of the biggest leadership challenges I had faced in my own career. I landed on a very different issue, something that's not particularly technical and has basically no code whatsoever. And that's the issue of retention on data science teams. And what we can do as data science leaders and managers to make sure that our teams are these thriving environments where our most talented data scientists want to spend years and years of their career. And I think I really started to think about this topic a couple years ago when I was managing a team of about 20 data scientists. And I'd had a pretty decent amount of success in my career. I had a PhD, I knew what I was doing technically. I'd built production models that made tons of money for the companies I worked for. I had helped elect a president, which I'll talk a little bit more about later. And then every week I was getting like several of these recruiter emails, like with super sexy job offers, like, hey, you're amazing, really flattering, like I want you to come and work at company X and we're gonna throw all this money at you. So basically like I kind of felt like I was riding high and on top of the world. And then one day I was having this conversation with someone on my team, pretty junior member of the team, someone who was really good, who I liked a lot, but still pretty junior. And the topic of recruiters came up and he was like, oh yeah, like those recruiter emails are the worst. I get like 2 or 3 of those every week. And all of a sudden it was like this bolt of lightning struck out of the sky. Like I had this realization, this kind of like, oh shit moment. Like I wasn't anything special, right? I thought I was special because I was getting all these emails, but I wasn't anything special. Every single person on my team was getting those same recruiter emails. And then I think there was this corollary that followed from that with this like mathematical certainty. The minute anyone on my team became unhappy with me, or they became unhappy with the company or the work that they were doing, all they had to do was like tune in to this never-ending stream of recruiter emails, like pay attention, reply to one, and like that, in 2 weeks, they'd be gone. And I'd be left with this hole that, as any of you who raise your hands saying you're managing teams now knows, it's really hard to fill those holes. And so that is actually what I wanted to write this talk about. And this is my little bit of anecdata, but it's not just anecdata. Like the real data bears this out. So Figure 8, it's this crowdsourcing company, and they recently released this report, this data scientist report on kind of the state of the industry. And one of the questions they asked was, how often do you get contacted by recruiters for new job opportunities? So 30% of data scientists said several times a week, 20% said once a week, and then another 25% said several times a month. So if you want to aggregate this up to something a little pithier, like 85% of your data scientists are getting contacted at least once a month, 50% are getting contacted at least once a week, and 30%, basically 1 in 3 of your data scientists are getting contacted several times a week about new job opportunities. And I think the data also shows that like this, at least some data scientists are listening to this kind of like siren song of the recruiter. So this is some other survey data from Katie Nuggets, the blog, the data science and analytics blog. And they asked folks how long they stayed at their previous job and how long they were planning to stay at their next job. So the solid bars show how long folks stayed at their previous job, and the dashed line how long they were planning to stay at their current job. So you can see like the modal number here is like somewhere from 1 to 2 years for their previous job. Like people are always a little bit more optimistic about their current job. Like, yeah, I'll stay 2 to 4 years. But either way, like the turnover in data science and analytics is actually pretty high. And I'm sure, again, those of you who are managing know it's really, really hard to fill these gaps once people leave. This is data from a report that IBM released not so long ago about the average time to fill a position in various kind of data technical roles. So, data-driven decision makers, analysts, data scientists, analytics managers, and they claim anywhere from a month and a half to 2 months average time to fill these roles. I don't know about you, that seems a little optimistic to me. I think I've often found it can take 2 to 3 months to find a really good person to fill these spots. And then again, this came out just last month. Like LinkedIn does an annual workforce report where they look at job postings on LinkedIn and then the skills people post on LinkedIn. And they're estimating that there's a shortage of 150,000 people nationally right now with data science skills. So given all that, I think the thing that's obvious to conclude is that the best thing to do is to keep your data scientists from leaving in the first place. And so that's why I decided to write this talk. The question is like, what can we do about that to keep our best data scientists from leaving? And so I've seen companies and teams make some avoidable mistakes. I've made some myself. But I hope that by the end of this talk, I'll have convinced you that there are really some like simple, concrete, and often pretty inexpensive things that you can do to keep your data scientists really engaged and productive and performing their best for your business. That a little bit of care and feeding and thoughtfulness about your data science teams can go a pretty long way. So here's the outline for the talk. So first, I just want to spend a little bit of time telling you about my background. Just if I'm going to give you management advice, I feel like I should convince you that I probably know a little bit of what I'm talking about. And then I want to zoom into kind of like the meat of the talk. Some thoughts around organizational structure and leadership for data science teams. Some thoughts around infrastructure and tooling. And then to some process issues, which I like to phrase as too agile or not too agile. And then I think probably my favorite part, or the thing that's closest to my heart, is the topic of continuing education for data scientists. So first, a little bit about my background. So I think I can summarize my story pretty quickly in 2 photos. So this is me circa 2007 when I was more science than data. So I was at the South Pole doing a physics PhD in Berkeley, helping to construct a particle physics detector. It wasn't even collecting data at the time. And then this is me in November of 2012. So in 2011, while I was doing a physics postdoc, I saw this job posting, again on Katie Nuggets, one of my favorite blogs, from the Obama re-election campaign, where they were looking for scientists and computer scientists and statisticians to come to Chicago and use their technical skills to work on the election. Luckily, I was already in Chicago, so I decided to take the plunge and joined a team of folks that were doing predictive modeling of voter behavior, survey science, and then all sorts of digital fundraising, experimentation, and modeling and optimization. So back then, that journey from physics into data science and campaigns was kind of novel. I think today it's a little bit of a worn-out cliche. But since then, I've basically been starting and leading data science teams in kind of the technology industry. So right after 2012, I started the data science team at Braintree Venmo. So Braintree is a payments company, and they own Venmo, which is a kind of a peer-to-peer money sharing app, which was eventually acquired by PayPal. Then I spent about 4 years at Civis Analytics, which is a startup that actually spun out of the Obama campaign to do data science consulting and software. So I ran the data science R&D team, 20 really amazing data scientists, lots with PhDs, doing software and algorithms and client consulting work for political campaigns, nonprofits, and a lot of Fortune 500 companies. And since then, I have been at ShopRunner building a new team from the ground up of about 7, working on some difficult and really interesting problems in the e-commerce space. So I'd estimate over my career, I've probably interviewed hundreds of data scientists, hired about 25, and probably lost only about 2. So as I said, I'm at ShopRunner now, so let me just spend a tiny bit of time telling you about our business and what we do. So if you don't know ShopRunner, the easiest way to understand our business is that we're basically like Amazon Prime, but for the other half of the internet. So we have 6 million members who get free 2-day shipping and returns and deals across this large network of 140 plus retailers. Companies like Saks and Bloomingdale's and Neiman Marcus and Lord & Taylor, kind of a concentration around high-end fashion and apparel. So this is often what our experience looks like. You're on Cole Haan, you're shopping for this like sweet pair of shoes, and you see this option here to log into your ShopRunner account and get free 2-day shipping. And then this modal pops up. Obviously, November 15th is not 2 days from now, so this is an old slide. But you can log in with an American Express card, with a PayPal account. So any of you who have an American Express card or a PayPal account, ShopRunner comes as kind of a loyalty perk of those programs. But fundamentally, we're actually a data and technology company. So our role is to try to pool together these retailers into kind of a data and technology collective almost to help them band together and try to fight the Amazon demon, I guess, as I would put it. So we're collecting many terabytes of behavioral data a month, granular SKU level browsing and purchase data that we can link across that network of retailers. We get product catalog feeds with prices and inventories and images and text, 10 million different SKUs every day. And the goal is to use this data to better personalize both our member and our non-member experience and to build new technologies and tools on top of that data for our retailers. And so the kinds of problems that we're working on, how do we, pretty standard but interesting e-commerce problems, how do we intelligently surface retailers and brands to our members based on their past browsing and purchase behavior? How do we recommend the right products at the right time? Some really interesting work around computer vision on this huge corpus of images, doing kind of automatic categorization and tagging of images, and then visual search and visual recommendations, and then all sorts of algorithms around a new consumer mobile app and browser extension. And we have a fairly typical, I would say, multilingual data science stack. So I'd like to end kind of this first section about my background with this. I don't know if you've seen this farmer's insurance commercial where like some giant cactus falls on top of a house, and then this dude comes out and he says like, "Hey, we know a thing or two because we've seen a thing or two." That's kind of a little bit how I would summarize my background. So like sometimes I was the one responsible for knocking that cactus over onto the house, but I've seen a lot across these 3 different teams and made some mistakes, and I'm hoping that you all can benefit from some of that experience. Okay, so now into some of the actual meatier portions of the talk. So the first thing I want to talk about are considerations around like organizational structure and leadership for data science teams. So the first thing, I think it's not a controversial statement, but I think it's worth reiterating that like good leaders and the right structure end up creating happy teams and happy data science teams. So the first thing I would emphasize is that data science is fundamentally different from engineering. So our work is less well-defined, it's often more experimental, it's iterative, it's very end-to-end, like you have to ingest data, clean it, understand it, build models, look at the output of those models, talk to the business. Like it's a very, very end-to-end, and you can't just hand something off kind of like an assembly line. And so I think I would argue that because of that, data science teams do best when they have a data leader rather than an engineer or a product leader. So I have known many people, and I've hired many people myself, who have left data science teams because they didn't have any kind of data science leader or mentor that they could look up to or learn from. So what I'm not saying is that your data science organization shouldn't be under your CTO in an engineering organization, or it shouldn't be in a product organization. But I think if you have a product manager who's actually like the boss of your data scientist, or an engineering manager who's the boss of your data scientist, that is sort of a recipe for disaster, because your data scientists will feel like they don't have someone to kind of look up to in their career or someone that they can learn from. So to the extent that you can actually hire that leader first, I think it makes a huge, huge difference in your ability to actually successfully build a team. The second thing is around structure of your team. So data science is inherently very, very cross-functional. And so often there's this tendency to dissolve data science teams into these fully cross-functional teams. Like take each one of your data scientists and embed them in a product team, and embed this person in finance, and embed all these other people. And I think unless you're a company of a certain size, like unless you're Facebook, or Google, where like you have 100 data scientists and you can do that, I think that's also often a recipe for disaster. So what I found is that data scientists, especially earlier in their careers, they get really lonely without other data scientists to talk to. They don't have other people to bounce ideas off of, or again, to learn from. And so I think the model that works better is to have a centralized data science team, and then you can still work cross-functionally, like assign your data scientists out to different product teams or out to different areas of the organization, go to meetings, go to stand-ups with those parts of the organization, maybe like sit with them sometimes, but they really spend more of their time on your centralized data science team, and they're going to be happier that way than working entirely with people who aren't data scientists. And also, to the extent that if you're hiring your very first data scientist, you can actually hire two, that is also much more successful. I've seen tons of people who are the first data scientists at a company who burn out and leave in 6 months or a year because no one gets them or no one understands what they're doing, and they can't actually learn anything from anyone else in their organization. Another organizational consideration I think is really important is to think about how you socialize data science within your organization. And one really effective way that I've seen this work in the past is to have brown bag talks about data science. So encourage your data scientists to give talks about either the basics of data science, like what is a model, how do you build a model, what do we do all day as data scientists, or to talk about some of the problems that they're working on, and do it over lunch, over brown bag lunch, and invite other people from the company, invite product folks, invite business folks, invite engineers. And I've often found that people are super interested in the work that we do, they just don't know anything about it, and they don't know how to approach it. And so this both serves a function of helping to train your data scientists to be better communicators and better presenters, and it also ends up building bridges out between your data science team and some other parts of the business. Another really, really bad mistake I've seen happen in the past is so I would sum up the lesson is to leave reporting to an analytics or a BI team. So I hope this is getting better, but I think there's been a tendency over the last 5 years or so for organizations to be like, I need to hire a data scientist, I'm super excited, I'm going to hire a data scientist, and then they bring them in, and what they want that data scientist to do is like pull SQL reports all day for like a year, or build a dashboard. And I'm not trying to disparage that work, like that work is really crucially important, right? So I've often thought of it as like Maslow's hierarchy of analytics. I don't know if you remember Maslow's hierarchy, but it's like at the bottom, first you need physical safety, and then you need water, and then you need food, and then at the very, very top, there's like art and symphonies and things like that. So I think it's often the same with analytics. Like first you need to actually collect your data, be able to put it in one place, report on it, et cetera. So like analytics and BI is really crucially important. It's just not what data scientists sign up to do 100% of the time. So the most successful organizations that I've seen have separate and dedicated analytics and BI and dashboarding teams where that's what they love to do and that's what they want to do. And then they have separate data science teams whose functions are algorithmic and predictive and machine learning and all that sort of stuff. But definitely do not hire a data scientist if what you want is someone to do SQL. And then finally, I think this maybe goes without saying, but I think it doesn't because people make this mistake. But the basics of good engineering management really still do matter for data science teams. And so that means like train your data science managers. Or if you are data science managers, ask your bosses for training about how to do management, right? Like many of us come from research backgrounds. Definitely like we weren't probably managers before all of a sudden we were thrust into this management role. And you mostly learn it by doing it and making mistakes, but there are people who've done this before who can train you and give you lots of help. And so ask your companies for that kind of help. And if you are leading a function where you have data science managers underneath you, give them training. And then the second thing, engineering has done this well for a long time, but I think since data science is new, this is not always the case. But create a technical promotion track. So don't force all of your data scientists eventually to become people managers just because they were good and they've been here for a while and you need someone to be in charge of your team. That's a recipe for disaster, both because if that person likes writing code and now they're forced to be a people manager, they're going to be unhappy. If they're a shitty manager, their team is going to be unhappy and everyone is just going to be unhappy. So if you're going to promote managers, make sure they actually want to manage people and not just, that's the only way to get up the career ladder or the only way to have more influence or more control over what you do. And so what we do and what I've seen work really well elsewhere is to kind of have, in engineering, you often have a lead engineer up to like a principal engineer where you have bigger and bigger ownership over complex projects. You're a thought leader and a mentor, and you have executive buy-in for things that you're doing. You're just not doing performance reviews and people management and things like that. So on my data science teams, we have lead data scientists and principal data scientists who are really good, but they just don't want to manage people, and that's a really good thing. So make sure that you do something like that. Okay, so now I want to turn a little bit to some considerations around infrastructure and tooling. Again, this is kind of a simple message to sum up, but one that I have seen be a problem elsewhere. So data scientists are going to leave your company if they don't have the tools that they need to do their jobs, right? That should not be controversial, but this happens. I've done it myself, in fact. So our work is inherently experimental, and it's elastic, and it requires a certain way of working or a certain set of tools, right? So you want to start doing some work on your laptop, and then maybe you on a small set of data. Eventually, you need a server. You need that server to have a ton of RAM, or you want to parallelize it across multiple cores, or you want to be able to spin up a cluster, or you want to train the model on GPUs. It requires experimental, scalable infrastructure. And if your data scientists either have to work on their laptop exclusively, or they have to go file a ticket with the IT department to get a server, and then 2 months later they come back and they give you the server, but it has the wrong version of Python, so then you file another ticket and IT installs that version of Python, but then you also need a package, and they come back 2 months later, people will leave, right? That is not the kind of environment that data scientists want to work in. So one way that I've seen this work really, really well is to set up, for those of you who are technology leaders or executives, set up dedicated cloud organizations for your data science team. So we have a dedicated AWS org on my data science team. It's linked up to our main engineering org for billing purposes, but we can go in there, we can boot up servers, we can boot up clusters, we can basically do whatever we want, subject obviously to budget. And we're going to do it in a way that we're not at risk of bringing down our production servers, because it's kind of a dedicated sandbox. But we have the power to expand our computing as we need to. And I think maybe this is a little bit controversial, but I would say if you don't at least have some cloud-based portion of your infrastructure, if you're a small-ish company, a small-ish team and organization, if you don't have some ability to expand into the cloud, I think you sort of have to forget about it. Like I said, if you're requesting a server for your data science team from IT and it takes a month or two, it's a recipe for disaster. Now, if you're in a larger organization with a giant data center that's on-prem, but your team can get access to expandable resources, I think that can work. Another good solution to this problem, if you don't want to set up these dedicated cloud provider organizations, is go walk the expo hall. There's a whole suite of tools that exist to solve this problem, these kind of collaborative data science platforms. So they're often notebook-based, but feature expandable computing. So Domino, which is kind of a Python and R-based solution for notebooks and scaling up computation. Databricks for doing self-managing of Spark clusters, Mode, and RStudio. A lot of other companies exist to do this, but so my current company, we're built around Databricks, and my data science team handles starting and scaling and killing all of our own Spark clusters to do whatever work that we need to do. To the extent that you can decouple your data science team from IT or DevOps, they're going to be much happier and much more productive. And I think, my apologies to the SaaS folks who might be in the audience, but I do think that the cutting edge of data science right now is really happening in the open source stack. So R, Python, Spark, TensorFlow, all these packages. And the data scientists on your team want to learn those things, right? Because they're portable, they invest their time into learning something that's going to be useful and that they can take from job to job. And so if they're inheriting these giant SaaS models and you're forcing them to only learn SaaS or other kind of esoteric proprietary languages, they're probably not going to be happy unless you have at least some plan or some component for working towards open source languages. Okay, so third part of the talk, I want to talk a little bit about process for running teams, and the phrase I'd like to use is to agile or not to agile. And actually there was an interesting talk yesterday morning from someone, engineering manager from Figure 8 who had this same title on one of her slides. It was all about Agile for data science teams. So if you get the video package, I recommend checking that talk out. So I'm sure a lot of you are familiar with Agile, but just to set the stage, I want to go back to this original manifesto for Agile software development. And I learned yesterday, actually, that this apparently came out of some ski trip with a bunch of senior engineers who, on the ski trip, decided they were going to put this manifesto together. So it's agilemanifesto.org if you've never seen it before, but they're kind of a set of principles. So we're uncovering better ways of developing software by doing it and helping others to do it. So we value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. So that is, while there's value in the items on the right, we try to prioritize or value items on the left more. And then this set of principles: deliver working software frequently, from a couple of weeks to a couple of months, with a preference to shorter timescales. Business people and developers must work together closely throughout a project. And then simplicity, the art of maximizing the amount of work not done, is essential. So that's the Agile Manifesto, and I think often what Agile has turned into in practice is kind of this set of formal roles and rituals. So you have Scrum Masters and product owners. If you don't know what a Scrum Master is, I found this description. If a product owner is captain of the ship, then the Scrum Master is first mate, responsible for crew welfare and making sure team members follow protocol. Sounds a little bit like an enforcer, I guess. And then a set of Agile meetings, so backlog groomings, sprints and sprint plannings, and pointing tickets and stand-ups and retrospectives. Your tasks are estimated, you measure velocity and burn down and things like that. So I think especially for data scientists, again, many of whom come from a research background, a lot of the formal Agile process feels like it can stifle creativity a bit and can often leave you feeling a little bit like this, like you're just this cog in a machine, like moving tickets from one part of the Jira board to another part of the Jira board. And so I think that what I recommend is trying to embrace the Agile mindset more than necessarily the formalities of the Agile process. And so I wanted to get a sense of this among data scientists, and so I did the most scientific thing I could, and I did a Twitter poll. And the question was, for my data science friends, how do you feel about Agile? It's great, we should just adopt it for data science teams, I hate it, or the mindset is more important than the formal process. So probably shouldn't judge too much from n equals 11 data points, but 3 to 1, people thought that it was the mindset that was important more than the formal rituals and the formal process. So what do I mean by the Agile mindset? So let's go back to some of those things from the manifesto. So responding to change over following a plan. So I think that actually fits really, really well with how data scientists work and how data science teams should operate. So data science, our life cycle is iterative and it's constantly changing depending on what you find in the data. You may ingest the data, prepare the data, build a model, the results are garbage, you go back, you figure out something was wrong in your ingestion or your data cleaning, and you're constantly in this iterative loop where you had a plan, but the plan broke down once you actually started to look at the data or build a model, and so you have to respond to change. And your data scientists need to be able to go where the data leads them, and they need to have the freedom to explore new ideas iteratively rather than knowing what you're going to find sort of at the outset. Second thing is, deliver working software frequently. I think this is often a pitfall that data scientist teams fall into. So I think it's really important for teams to produce as much as they can quickly, and that can take a lot of different forms. But often, internal applications that a stakeholder can play around with, some sort of internal visualization to play with a model result or an algorithm result, incremental presentations, any of those things are essential for getting buy-in for your data science work. And so the part of the Agile process I think that is really good is that often at the end of the sprint, the Agile sprint, there will be a demo phase where you're supposed to demo working software. So to the extent that you can get your data science team actually demoing incremental results to business folks quickly with kind of internal applications and visualizations, I think that does a really great job of increasing buy-in. And then finally, business people and developers must work together daily throughout the project. Again, we as data scientists have to work hand in hand with the business to understand how data is generated, how our models are going to be used, and what will actually end up providing the most value. And then finally, simplicity, maximize the amount of work not done. Again, that fits with what should be the good attitude of a data science team. Deliver a simple logistic regression baseline before you go off in your cave for 6 months to build your deep learning model. Actually, don't ever do that. This was the best image I could find online for agile fail. I think going away for 6 months to build your deep learning model is going to be an agile fail. Okay, so the last section of the talk, which I think is a little bit my favorite and I think can often have the most impact, is this topic of continuing education for data scientists. So the way I often phrase this is an important psychological thing to understand, which is that FOMO in data science is a real thing. So if you're not familiar with FOMO, it stands for the fear of missing out. So it's this idea that something cool or interesting is happening off over there, and you're not a part of it. In data science, that often takes the form of my company is not doing any cool machine learning projects, or we're not doing big data, or we're not doing Spark, or we're not doing deep learning, or we're not doing reinforcement learning, or we're not doing insert cool technology X in the box. And that again is a little bit borne out by the data. So this was from a recruiting survey about the factors that would motivate folks to change jobs. Obviously, salary's up there, right? If you're not paying your data scientists competitively, that's a problem. But the other two things are around growth and career growth and learning opportunities, right? So our field changes so quickly, people are really, really motivated to keep learning and advance in their career and learn new things. So what can we do about this, my company isn't doing any cool machine learning stuff attitude? I think there are a handful of things that you can do. First, it starts at hiring. Hire data scientists who care about having a real measurable impact on your business and celebrate those things rather than just using the newest, shiniest tools. As a leader, you should be able to convince your team that that's what matters, but let's assume that you've done that already. What are some things that you can do to keep your team feeling like they're learning and staying on the cutting edge? So one, again, super cheap but effective thing I found is to institute a journal club. So this can be very informal, again, done over lunch, but people, read an article, pick a blog post or pick something from the research literature. Someone can present it, or everyone can just have a discussion about it. And open it up to other interested parties. A lot of engineers come to our journal club because they're just interested. So that's a great source of cross-pollination. And if you're looking for sources of paper ideas, this blog, The Morning Paper, is a great one to check. It's a blog post summarizing a research paper every day. And you, as a data science leader, I think really should set the example. So you have to read widely, keep familiar with what's happening on the cutting edge, and share the things that you're reading on Slack. If you see something interesting in an article, share it with your team, encourage them to read it, encourage them to start sharing articles in Slack, and create this culture where you're all learning from each other. And I stuck a link down here to a handful of my favorite kind of data science newsletters and aggregators that I think are some quick ways to keep up with a lot of what's happening on the cutting edge. And then last thing, again, which is kind of corny, but also sort of effective, is to have a data science movie night. It doesn't have to be at night, it can be in the afternoon, but this talk is being recorded, PyData talks are recorded, conference talks are recorded. I have this long, never-ending list of talks that I want to watch and learn from, and I have a 2-year-old at home, so I never get to do it at home. Literally, I've done this, buy some popcorn, take an hour, get a conference room, and watch an interesting video from one of these conferences with your team. And they'll be happy because they actually have the time they set aside to watch it when they probably don't have the time otherwise. Another effective technique, it's a little bit controversial, but with teams I've done before, allowing them to take hack weeks. So you can decide what cadence to do this. We did it quarterly at Civis. Could do it once a year, could do it twice a year. But we sort of iterated and landed on a hack week, and I think that was for a good reason. So hack days and these kind of 2-day company hackathons, they don't work very well for data science. You can't really do much in a day or 2 days. And so we iterated and ended up giving folks a week to work on a project. So that could be exploring a new software package or a new language, a new technique or tool, doing something with your company's data that they couldn't do as part of their day job. And it is literally amazing how many times someone does something in a hack week that you end up integrating into your product or your work, or that pops up again later. Because people don't just pick random things, they often pick things that they wanted to do, but just didn't have time to do in their day job. I think there are a couple important things to keep hack weeks important. So you need to have a concrete outcome that's planned in advance. Have someone write down what that goal is for the week. Plan it out again in Jira a little bit and force them to do some sort of daily check-in with another member of the team. So like, don't just let them go off for a week, but at the end of the day, just have a 10-minute conversation with a buddy on the team to talk about what they did that day. It creates just that little bit of tracking and accountability so that they're actually kind of forced to do something. And then we would mandate an end of the Hack Week presentation to the rest of the team. So that could be like going through a notebook, documenting the code, or showing an app prototype or something like that. That's both a good way to keep the Hack Week on track, but then also for the rest of the team to learn. So finally, have a conference policy. So it's great, you all are at a conference, right? But does that trickle down to your data science teams? So the policy I've had at places is to encourage folks on your team to submit abstracts to conferences, and if it gets accepted, pay for them to go give the talk. It's a great opportunity for them, it's a great opportunity for your company, and it keeps everyone happy. And I mean, it's rarely going to be a problem that someone's like got 12 talks accepted and you're constantly paying for it. If it is, like maybe that's a good problem to have. And then if it's in your budget, fund one conference a year just for someone to go to and attend as a learning opportunity. And if it's not in your budget, again, like use that journal club or that movie time to have them watch talks from conferences. Here are a handful of my favorites. PyData, if you're in SciPy, if you're in the Python stack, use RStudio, Conf if you're in the R stack. And then a lot of the more academic conferences, KDD and ICML and NIPS, although NIPS is apparently impossible to actually buy a ticket for these days. I think it sells out in like 5 minutes. Perfect. So hopefully I've convinced you that with a little bit of thought and mindfulness and work, you can keep your data science teams happy and hopefully avoid that sort of retention trap where you're constantly having to refill these holes. I hacked together this image because I really like it. I think often we think of data scientists as these like powerful unicorns, right? Like doing this magical stuff. But I actually think if you think about the psychology a little bit, data scientists are more like a little bit of like fragile baby dragons, and you actually need to think about taking care of them. Like we have fragile egos and feel like we're not doing cool stuff, and everyone else is like doing cooler stuff than we are. And so if you understand that psychology a little bit, I think it helps you like craft an environment that keeps people happy. And that's it. Hopefully, well, just about out of time, but maybe we have a minute or two for questions. I don't know. So, thanks.
These two questions, and then I think we're out of time. Hi, I'm Bonnie Cruft. I'm with GSK. I actually have two questions, but hopefully they're short questions.
Okay.
So one is about the size of data science teams. So I think typically people work in the model of, say, between 5 and 10 data scientists. But then, as you mentioned, there's the bigger teams like you have at Google where there's 50 to 100.
Yep.
What do you think are the added challenges with having a very large consolidated team?
Yeah, so there's some point at which you transition from a team that makes sense to have as like one team to where you need some substructure. So on the team I managed that was 20, like we had to have some substructure on the team. And then I think it just becomes a matter of figuring out what substructure makes the most sense for your organization. So we had almost like a platform team that focused more on software, and I think this is probably borne out by like the Ubers and the Airbnbs of the world, like a team that focuses on making tools to keep your data science team effective. We had a team that focused more on client consulting work, and then you could even specialize within those different consulting verticals. So I think like it just depends on your organization, but at a certain point that's probably around 10, you do have to have some substructure on the team with like managers of the different functions, and then just figure out what subject area makes sense for that.
Great, thank you. And the second question was around continuing education.
Yep.
So I liked all that you mentioned about journal clubs, sharing in a forum about things that are going on in the organization. But what about formal training? Do you see benefit in buying a Safari license for your team or sending them on courses or things like that are?
Yeah, absolutely. So I mean, ShopRunner actually does have like a tuition reimbursement that we have used. Actually, we're using next week for like a Databricks Spark training. But I think in my previous company we also had Safari lessons. So I do think like if your company has the budget to do things like that, Hillary Mason talked this morning, and those Cloudera Fast Forward Lab reports are really, really awesome. Like, all those formal things are great, and I think if you have the money for it and you can encourage your team to do it. Another thing that our engineers just generally are super interested in is like public speaking training and learning how to give presentations, and like you can pay to do that, and your team will be super happy with that as well.
Okay, thank you, and one more question.
Hi, I'm Meta Morales from Vertex Pharmaceuticals. My question is also about structure, but kind of a different angle. I've noticed on teams many times you have data scientists who will focus kind of on their, model building or whatever the case may be, without fully investing in the full business problem. And I wonder how, in your experience, the structure and processes of the team have kind of, encouraged those data scientists to view the full problem as within their scope of responsibility.
Yeah, so I think that gets at some of the like nebulous cross-functional aspects. And so I think that's where like trying to lightly embed that data scientist into some of these other teams can help. So at ShopRunner, the whole engineering team does do kind of agile 2-week sprints. And so a lot of times like a data scientist who's working on a problem will go to the stand-ups, the daily stand-ups for this other team that they're working on a problem for. And so they'll talk to the product manager, they'll talk to the engineers, and they'll understand more of the business scope. So it forces them to like get up from their desk and actually go be with that team a little bit more. At Civis, we did a lot of consulting work. And so like, again, folks from my team, like, so someone might have been on the embedded on the political team, and so they would literally go to the weekly meetings of that political team, or the political team had questions, they would know that they would go to this person first, and so it just like opens up those lines of communications and forces your data scientists to get out of their comfort zone a little bit. So like to the extent that you can find a way to get that data scientist to go maybe embed with that team or go to their meetings a little bit more, or to actually maybe even remove yourself from the equation a little bit, like send them to a meeting that you might have gone to otherwise. Like don't be the mediator and then take the information and give it to that person. Like either bring that person with or force that person to go by themselves to collect some of that information, I think can be effective. So. All right, cool. Well, I think we're out of time.
Let's thank our speaker one last time. Thanks.